today. So yeah, I'm going to be talking to you about the Tactile Universe project and the work that I've been doing on that as part of my role as an Outreach and Public Engagement Fellow at the University of Portsmouth. This is obviously an astronomy project, and you might be asking yourselves, why is he talking about this at a biology conference? But I'm hoping that there are some lessons that we've learned in delivering this project that some of you might find useful if you want to pursue work like this yourselves. So we can jump to the next slide. Okay, so I always start off with a statement, and that statement is that astronomy and a lot of other sciences, to be perfectly honest, are often perceived to be really, really visual subjects. So this is in the way that we communicate them, the way we educate people about them, even the way we do our research can be really, really visual. And for that very reason, these subjects, particularly astronomy, can be really, really difficult for people who are blind or vision impaired to access. Just because we lean so heavily into the visual. And the reason I care about this so much is because I'm actually somebody with a severe vision impairment. So I was born with my vision problems. My lifelong dream was to become an astronomer, but it definitely wasn't a particularly straightforward path for me to sort of get to there, to realize that dream. And so much of that was because of this difficulty of access, actually accessing the stuff I needed to access to learn about astronomy to become an astronomer. So we can jump to the next slide. Okay, so shortly after I moved to Portsmouth, collaborating with a few of the other researchers here, we came up with the idea for the Tactile Universe project. And so we started this back in 2016. It's a public engagement project. And the core of this is that we use real data, so real astronomical images, and we turn these into tactile models that people can feel instead of looking at to learn about astronomy. And the hope here is that we're going to enable people who can't see or have low vision to access astronomy, but also allow people who can see perfectly well to access astronomy in new and unique ways. So we jump to the next slide. Okay, so the main aims of this project are to help young people, I guess, show young people that they can do STEM subjects, they can do things like astronomy, even if they think they can't, even if they're somebody with a vision impairment, even if they've come up against all of these barriers. We want to show them that there are ways that they can do STEM if they really want to, show them that STEM is for them. We also want to develop, obviously, and share resources that people can use to engage with people who are blind and vision impaired. These could be used for research or for education. We also want to show other researchers and public engagement people that there are ways that they can make their own projects more accessible if they really want to, that they can sort of include people from underserved communities in lots of really weird and wonderful ways. And last, we really want to demonstrate that accessibility helps everybody. So if you go into something trying to make it more accessible for a particular group of people, you almost always make it more accessible to everybody. And so that's something to bear in mind moving forwards. Okay, next slide. Thanks. Okay. So I was talking about how astronomers lean into the visual a lot when we talk about space. And so this is a really, really good example. So this is a picture of a galaxy. So a galaxy is this big collection of gas and dust and stars and planets and all these other things. And it's all bound together by gravity. But you can see in this image, there's a lot of detail. So it forms this amazing shape. It looks a little bit like a whirlpool. There's lots of color, there's lots of detail. We can see where the dust is sort of blocking the light of the stars that make up this object, and where the gas is being illuminated by those stars as well. The problem is, though, no matter how many words I use to describe this, if somebody can't see this image, it becomes really, really difficult to convey that sense of wonder. Because let's face it, this is a really, really beautiful picture, and astronomers, for very good reasons, lean into this type of stuff when they want to communicate astronomy, when they want to talk about why the universe is such a wonderful place. So we came up with a really simple solution to communicate images like this to people who are blind and vision impaired. If we can jump to the next slide. Okay, so the basic idea is we wanted to make tactile versions of these images that people could use their fingertips to interpret, that would give you just the same information that your eyes would if you were to look at an image. And so on the left-hand side, we have a telescope image of the galaxy Messier 51, that same one that I was showing you the color image of before. And on the right, we have the resulting tactile image that we've made. We've 3D modeled this, and then we've 3D printed it so that people can actually physically interact with it. And I'll just go through really briefly how this works. So we jump to the next slide. Oops. So the way this works is we basically model the light in the image as a 3D surface. So we take the brightest or whitest pixel and we make that the highest tactile point in the image. If we go to the next slide. We take the darkest or blackest image pixel and we make that the lowest point, so closest to sort of the base of the model or the background of the image. If we jump to the next. And then in between all of that, we scale the height based on sort of how grey, so how close to white or how close to black those image pixels are. And so what we end up with is almost like a height map that represents that change in light that your eyes would interpret as an image. And so really you can run your fingers across this image, you get a sense of where the brightness is changing, you can feel the overall shapes of these objects, you can pick up some of that detail that's present in that visible image, but just using your fingertips. Okay, we jump to the next slide. So one part of this project that was really important to us was actually making sure we were developing something that was going to be useful for members of the blind and vision impaired community. And that may sound like a bit of an obvious thing, but so even though I'm somebody with a vision impairment, it became really obvious really quickly that what worked for me wasn't necessarily going to work for anybody else. Everybody with a vision impairment has learnt to adapt, has developed their way of sort of doing things quite uniquely. And so what works for one person is not necessarily going to work for somebody else. A way of describing something, if it relies on particular analogies, isn't going to work for everybody if people don't have those analogies in their heads already. So we actually engaged with a local vision impaired support group to test our models to make sure that they were going to work, to make sure that we had things like the tactile height of those features at a level where people could detect them with their fingertips, where they weren't uncomfortable to touch. But we also did a lot of work with this group to make sure that our explanations, our descriptions were all based in some kind of language that was going to be understandable to people, even if they didn't have visual references to fall back on. If we jump to the next slide. Okay. And so this resulted in models that look a little bit different from those initial pictures I was showing you. And these are all improvements that were made based on conversations with these people who were blind and vision impaired. And these were ideas that we would never have come up with on our own. So on the left-hand side is the front of our tactile image, 3D printed. And on the right-hand side, we've got a picture of the back of the image. So on the left, you notice we've included a nameplate, and so this helps people orientate the models. It's also a quick way of identifying which models people are holding. Around the outside of the image, you'll notice there's also a raised border, and this border is the same height as the brightest point on the models. So it acts as sort of a yardstick. People can bridge their hands between that border and any part of the model and work out how bright that part of the model is compared to that sort of brightest feature. So it gives people a way of orientating themselves, measuring the brightness of that different part of the image. And then on the back side of the image, we've also included a picture of that galaxy. So that very image that was used to make this tactile model. The reason for that is that there are a lot of people who have a little bit of vision, not very much, but the number of people who are totally blind is actually quite small compared to the overall sort of vision impaired community. So we wanted to make sure that if people could see something, they had something they could look at while touching the image to make the best of what they have. So to use some combination of what they can see, what they can touch, to interpret these models as well. And so this gives people, the option to use whatever sense works best for them when they interpret these images. So if we move to the next slide. Okay, so moving on from this pilot phase where we worked with the local people around Portsmouth, we got some funding from the STFC through a Nucleus Award in 2018, and we decided we wanted to do a number of things. So we wanted to create physical resource kits that we could send out to other people so that they could use our resources with their local blind and vision impaired communities. We also wanted to create a set of inclusive workshops that people could deliver to school pupils rather in upper primary, lower secondary, so that they could engage with astronomy and start to get inspired with the kind of research that people around the UK are doing. We also wanted to train other people to use these resources, so that again, we're quite a small team of people at Portsmouth. We wanted to make sure that these resources were getting out to as many people as they possibly could, and we figured the best way to do that was to train other people to make sure they were comfortable delivering the resources in their parts of the country as well. And last but not least, we also decided we wanted to release all of this for free. So we wanted to release our 3D models, we wanted to release instructions for building those models, instructions for printing them, the lesson plans that we'd put together, as well as the code that we use to make our 3D models. And that code is really versatile. You can basically put any black and white image through it, and you can make your own tactile image. So the hope there is that people will be able to access these resources and use them in lots of ways that we would not have thought of on our own. Now, if we go to the next slide. Okay. So again, a lot of this work involved working with local blind and vision impaired students to make sure we were developing stuff that would work well for them. And so we enlisted a lot of help, sat down with sort of through multiple sessions to work with some local students to make sure we were developing workshops that made sense to them and that they would enjoy. If we jump to the next slide. Okay, so starting off in the first workshop we run with upper primary school students, we deal with the solar system because it makes sense to start off small, because if we jump straight to something like galaxies, we're dealing with really big sizes, really big scales, quite complex systems. We wanted to start off at more local scales where we could talk about things that were a little bit more relatable. So we run activities where we talk about the different sizes of the planets in the solar system. We use common household objects like tennis balls, ping pong balls, mustard seeds, peppercorns to talk about the comparative sizes of the planets in the solar system. We use a peppercorn as the Earth and a big beach ball as the sun, just to get that sense of scale across. And we get students to build their own tactile map of the solar system spread out along the length of a till roll to talk about the separations between the planets. If we move to the next slide. We then take a step out and we start talking about, so in the second workshop with upper primary school students, we talk about the Milky Way, we talk about the night sky, we talk about how we see our Milky Way galaxy from the Earth, and we get students to build their own model Milky Way galaxy using a CD and some Play-Doh so that they can get a sense of the overall sort of shapes that we're talking about when we talk about galaxies. So these beautiful sort of spiral arms stretching out from the center and all those other features. If we move to the next slide. Then last but not least, we tackle galaxies. And so we have a selection of different kinds of galaxies, and we can use these to talk about what makes galaxies the shapes that they are, how galaxies change through their lifetimes, why galaxies just look so different from each other. So there's a lot of versatility in how we can use this set of models. We can get students to do sorting exercises where they try and come up with their own classification scheme for galaxies, a little bit like the Citizen Science Project Galaxy Zoo that you might have heard of. And next slide. Okay, so with all these models in hand, these lesson plans, in 2019 we ran 5 presenter training workshops across the UK. These were attended by 66 researchers, science communicators, teachers, members of the public who were interested in the project. And we basically spent a day training them to use these resources to run our workshops and to feel comfortable with the idea of talking about science to a blind and vision impaired audience, because there was a lot of stigma. People were really worried they were going to say the wrong thing, they were going to use the wrong language, they were going to insult people or give people a bad experience that would turn them off science instead of making them excited about the idea of doing science. So overall, the workshops were really, really well received. We're hoping we can run a few more of those in the future, but we'll have to see. After those workshops, we then set out 20 resource kits to people we trained so that they could use the resources to deliver the workshops to their local blind and vision impaired student communities. And just before the first lockdown hit, some of those groups had sort of just started to engage, and they were sending us some wonderful feedback from students who'd encountered our resource and were starting to get a little bit more engaged with astronomy and other topics like that. Okay, next slide. Yep. And this is just a picture, lastly, from one of those workshops. You can see there's a lot going on. On the left-hand side, we have a totally blind woman who's part of a theatre company who wanted to come along to the workshop to see what we were doing and what we were all about. And in this picture, she's actually describing to everybody what she can feel in her own language, and they're feeding back to her with their own language as well. So basically, all the people we're training are helping each other develop different ways of talking about these resources in more accessible ways. And you can see just how chaotic this was. These training workshops were a lot of fun. We engage with lots of really wonderful people, and we hope as restrictions begin to lift again, as people start going back out into schools, that these people will be able to help us deliver our resources to lots of students around the UK. Okay. And last slide, I think. Yep. And so lastly, if you want to engage with any aspect of this project, if you want to use our resources, if you want to download the code that we use to make our resources to make your own tactile images, these are the various ways you can get in touch with us. So you can email us at tactileuniverse@gmail.com. You can visit our website, www.tactileuniverse.org. That's where we have all of our resources hosted. We're about to post a whole bunch of training videos as well that you can use to learn how to use these resources. But we also host that code that you can use to make models if you want to. And we're also on Twitter at Tactile Universe. And yeah, thank you so much.